Good morning, CP Pre-Calc. Now we're going to get further into parabolas today. Now we talked about what a parabola was yesterday when you did your Desmo activity, and you kind of analyzed how the directrix and focus point moved your parabola around on a coordinate plane. So let's just go over. I had the parabola definition in your assignment yesterday, but I just want to recall it. A parabola is a set of all points x and y. All right, I'm going to write a little. So let's see, is a set of all points x, y that are equidistant from a fixed line, the directrix, and a fixed point, the focus, not on the line. Hold on. All right, guys. So if you take a look at this, this is an example of a parabola. All right, guys. So that means that every single point on that parabola will be equidistant, meaning if this is D1, this would also be D1. These would be equal distance. The line down here, this would be my directrix. All right. And the focus point will be inside your parabola. So if I looked here, this would be my focus point. All right, guys, that would be my focus point. All right. When I take a look at my diagram. Now, we're going to also start using a simple term also, just to be simple when you hear it. The term is going to be called the magic distance. Now, the magic distance is really going to be, let me pick a better color, the distance between the focus and the vertex and the directrix. Okay, that would be perpendicular. That magic distance will always be obviously the same. All right, so we're going to call that distance down there. Let me put 2 in this one to differentiate it. When I talk about the magic distance, that is what I'm talking about. The distance between the vertex and the focus and the vertex and the directrix. That distance will be exactly the same. Okay, so that's what I'm referring to. So now what we're going to do is there's 2 types of parabolas we're going to work with now. We are so used to working with a typical up and down parabola, but we're also going to work with a side-to-side parabola in this case. So there's going to be equations for both. When we have an up and down parabola, all right, we're going to have a new form when we're dealing with conics. So the form we're going to work with here in the up and down is you have x minus h squared will equal 4p y minus k. 4p y minus k. And the one thing I want to just emphasize is that p will not equal 0. That is for my up and down parabola. Now, if I wanted to talk about a side-to-side parabola, the form will be slightly different. It's going to be y minus k squared equals 4p x minus h. All right. And again, p will not equal 0. Okay. Now, there's a couple of things we want to be able to identify. First of all, this will have our first one here. This will have a vertical axis. So it will have a vertical axis of symmetry that goes through the focus and the vertex. All right. So this one will have, this is our vertical axis. While over here, we will have a horizontal axis. Mm-hmm. Now, I also want to give you some information when we talk about the directrix and the focus. Now, if in our first one, when we talk about the directrix, the equation of the directrix will be y equals k minus p. So this line down here will be y equals k minus p. That is the equation for the directrix when we have an up and down parabola. The equation for the focus when we have an up and down parabola will be h comma k plus p. So that point will be h comma k plus p. And remember, when I think about any type of parabola, that point right there will be my vertex, and that will consistently always be hk, and that will be hk in both of them. All right, guys. Now, it'll differ if you have a side-to-side parabola. So if I have a side-to-side parabola, this will all differ. Your directrix is no longer in the first one. If I look here, if I go up and down, my directrix is a horizontal line. So I have y equals. In the second one, when I'm looking at my side to side, my directrix is a vertical line. So my equation will be different. So when I look at that, my directrix equation then would be x equals h minus k. That's the directrix equation. Okay. The focus point will be h plus p comma k. Your focus will be h plus p comma k. All right. And this is the stuff that we're going to have to know. All right. You'll also know that if you look at your parabolas, they will always open up where the focus is inside your parabola and the directrix is outside. All right. The parabola will never intersect your directrix. So make sure that you make a note of that in your head. Okay, guys. So let's go to our next page and let's go over an example together. Number one thing. The first thing you want to do is identify whether it's opened up or opened down. The easiest way to do that first is see what's being squared. X is being squared. So go up here. In which one of these equations is x squared? The up and down has an x squared. In the side to side, y is being squared. So what I want to do is keep the x squared on one side and move my y terms to the other. So let's take a look at that. So I'm looking at that form now. If I have x squared, so I have x squared equals, and I move that 8 to the other side, positive 8y. All right. So we're going to go through what we need to know. Now, the formula, this is definitely by having that x squared, we are saying this is an up and down. This is up and down. All right, guys. So let's talk about a couple things we want to know. Now, the other thing I should, so that's an up and down. So let's start there. Now, let's take a look at what hk would be. Now, remember that formula. That formula was x minus h squared equals 4p y minus k. So you want to look what's being subtracted from x and what's being subtracted from y. So if I want to find my vertex, if I'm looking for that vertex, that hk, what's being subtracted from x? Nothing, so it's 0. What's being subtracted from y? Nothing, so it's 0. That is the vertex of my parabola. All right. Now, I also know that in this case, I have a vertical axis. So I have so we also know this is it's up and down. So we have a vertical axis. That means we'll have x equals a value. If you have an up and down, it's going to be x equals h is that vertical axis. So in this case, my vertical axis will be x equals 0 because h is 0. Okay, so we're going through a couple steps. So the next thing I want to do is I want to find out what p is. Now, I want to make a note. P is my magic distance. P represents the distance between the vertex and the focus and the vertex and the directrix. So P is the magic distance between the focus and the vertex and the directrix and the vertex. So when I go up, if I want to go back up here, this distance here, this would be, if I looked at this would be the length of P. This down here would also be the length of P. Same here. If I looked over my other side, okay, just for my side to side, this here would be P. And the distance between here and here would also be P. The directrix and the vertex and the focus. So that's my magic distance. So I need to find P. Now P will help me find the equation of my directrix and the focus point. So if I look at the formula right in front of my Y, I have a 4P. That 4P in this case would have to be equal to 8. So if I know that 4P is equivalent to 8, I know that P would have to be 2. I found that magic distance. So then that helps me now find the focus point and the directrix. So if I want to see, let's take a look at this. If I want to find my directrix first. So let's take a look at that. If we find that directrix, the equation, when we wrote it down up there, was Y equals K minus P. Well, what's my K value of my vertex? K value was 0. P is 2. Y equals 0 minus 2. So Y equals -2 is my directrix. So now I look at that and I say, okay, well, here's my directrix. There. Now I need to find my focus. Now, if I want to find the focus, the formula I had was H K plus P. Well, H is 0, K was 0, and P is 2. So 0, 2. That would be my focus. Now, once I have all this information, I can graph it. And we're going to keep the graph simple. All right, guys, I'm not doing anything fancy with my graphs. So when you graph this, okay, first thing, graph the vertex. We know the vertex is 0, 0. So I'm going to graph, actually make some lines so it helps. Now, all I want you to graph is the vertex, the focus, the directrix, and the axis of symmetry, and label your part. So if I go do this, my vertex is at 0, 0. So I'm going to go to 0, 0 and put a point. Okay, that's my vertex. My axis of symmetry is x equals 0. That's a vertical line through that. So I'm just going to dash it. That's my axis of symmetry. It's a vertical axis. My directrix is y equals -2. So I'm going to go to -2. Y equals is horizontal, and I'm going to put a horizontal line through -2. My focus is 0, +2. So I'm going to go and put a focus point at 0, +2. And then I'm just going to open it up. I know that my graph opens up towards the focus and away from the directrix. So I want to label. If I want to label, I put y equals -2 as my directrix. And I put, that is my focus would be 0, 2. And it opens up. I don't need any other points on the parabola. That would be it. Okay, guys, let's go to our next example. So now this one's slightly different. What is being squared? Well, in this case, y is being squared. If y is being squared, then I know I have a side-to-side parabola. I don't want to write this thick. That was just to get the points. So I know I have a side-to-side parabola. Now, we're going to have to use the method we use with circles with completing the square. But the key to first is move everything with the y to the left and move the x terms to the right. Because y is being squared. Whatever's being squared is the one that we're going to move. So, and we got to remember that our formula for this one, if I write this down, would be y minus k squared equals 4px minus h. All right. So I want to make it look like a side-to-side parabola. So if I take a look at this, what I'm going to do is I'm going to take that y squared. I'm going to leave that negative 6. I'm actually going to add 9 to the other side. And then I'm going to leave that negative 4x here. The reason I added 9 to the other side is because I knew that 4 and the 9 didn't have a common factor, but I also noticed that by adding 9 to the other side, I got a perfect square trinomial over here, which is our goal. We want a perfect square trinomial on the left side of our equation so that we can rewrite it in the appropriate form. So if I look at this problem, I have a perfect square trinomial. I'm going to write y minus 3 squared when I factor it equals negative 4x. And then we're going to go through the same process we just did, except we're using the side-to-side formula. So if I take a look at this, now I start with my vertex. Vertex is still hk. The order does not change. H is always first. H represents the x. Well, if I look over here, what is being subtracted from my x? When I look over here, nothing. So that means h is 0. What is being subtracted from my y? 3. That means k is 3. That is your vertex. Now we know we have a horizontal axis. What is the equation for horizontal axis? Now we take a look at this. If it's a horizontal line that goes through the vertex, horizontal line is y equals a value. So it would be y equals k. So what is k? K is 3. So y equals 3 is my horizontal axis. All right, so now let's go to our next thing. We need our directrix and our focus. But in order to find that, we need to find our magic number, which is p. P is that magic value. That magic value p. So let's see. Well, p, if I take a look, 4p has to equal negative 4. So I know 4p has to equal negative 4. So p, therefore, must be negative 1. Now, how does that help me? The equation for our directrix. My equation for my directrix in this case was x equals h minus p. So I look at h. H is 0. P is negative 1. I'm subtracting a negative 1. Well, when you subtract a negative 1, we're actually adding. So x equals 1 is my directrix. That is a vertical, I'm sorry, a vertical directrix. So now let's go to our focus. If I go to my focus point, I need to have h plus p, comma k. Well, h is 0, p is 1. So I'm sorry, negative 1. So it's negative 1. K is 3. So my focus, therefore, is, my focus point is negative 1, 3. Now we graph. Now again, guys, simple graph, nothing crazy. So I have my simple graph. Let's graph our vertex first. My vertex to come up is 0, 3. So I'm going to go 0, 3, 0, 1. Oh, wait, let me go. Let's do that in black. So, okay, so all right, so 0, 3, guys. I'll do it. Okay, so 0, 3. I'm going to make it a little thicker when I'm graphing. There is my vertex. That's at 0, 3. It has a horizontal axis at y equals 3. So I'm going to put that horizontal axis there. Then it has a directrix at x equals 1. So at x equals 1, I'm going to put my directrix. Then it has a focus at negative 1, 3. And then when we graph it, we open it towards the focus and away from your directrix. That's all I want to see. All right, guys, let's try one more. Now I'm going to start with number 1 here. Okay, guys, when we look at this, identify the following, sketch the parabola. Magic distance. Again, let me just label that. What do I mean by magic distance? That is P. All right, guys, that is my magic distance. Find the coordinates of your vertex, which are H, K. Coordinates of your focus differ based on whether it goes up or down or side to side. The equation of your directrix will differ whether it goes up or down or side to side, so we need to look at them. The axis of symmetry will differ whether it's up or down or side to side, so be careful. And the direction towards which the parabola opens, it always opens towards the, always opens towards the focus. All right, guys, it always opens towards the focus. That is important for you to know. The other thing you can say for when it opens, all right, if P is greater than 0, it will open up or to the right, depending if it goes up or down or left and right. If P is less than 0, it will open down or left. And a key thing to always remember, a key little hint is always opens towards the focus, but this will help you too. Now again, when you take a look at this problem, you see what's being squared. X is being squared. I know this is an up or down. Okay, so I know it's an up or down. So if I go by numbers, it says the magic distance. Magic distance means they want me to find P. What does P equal? Well, I know this is already in the correct form. So I know that 4P has to equal 12. So therefore, P would be 3. That's the magic distance. That's the distance between my vertex and my directrix and my vertex and my focus. Coordinates of the vertex are H and K. So let's do B, HK. What is H is what I'm taking away from X. K is what I'm taking away from Y. H would be 3 because I'm subtracting 3 from X. Now, the next thing I'd ask myself, what am I subtracting from Y? Well, it's a positive 2 there. So what makes a positive 2? Y minus a negative 2. You're taking the opposite of what's in the parentheses. That's my vertex. Now, because this opened, in this case, we said it opened up. It's going to open up or down. We know we have to follow the equation for the focus for up or down. So if I take a look at this and they want my focus for C, the equation in C for that focus would be, it's going to be H, comma, K plus P. So let's look at that. H is 3, K is negative 2, and I'm adding my magic distance of 3. So it's going to be 3, 1. That is my focus. Now look at the equation for your directrix. Your directrix equation was Y equals K minus P. So let's see. Y equals K minus P. Y equals K is negative 2 minus P is 3. So my directrix is Y equals negative 5. That's part D. The axis of symmetry. If it is going up and down, we said the axis of symmetry, what will it be equivalent to? It will be equivalent to X equals H. So in this case, X equals H. What is H? X equals 3. All right, guys, and we have this all written up here if you forget it. Like in example 1, take a look. Go back if you need to, okay? X equals H. Now, will it open up or down? Tell which direction the parabola opens. We said it goes towards the focus, number 1, but we know it opens up or down, and see, P is positive, therefore it opens up. So let's graph this. Take it step by step, nothing fancy. Okay, so I graph it. We just need the main things. So let's see, we said we need our okay, I think I have to make it a little longer. So let's take a look. If I graph this, first thing I'm going to graph, 3, negative 2. That's going to be my vertex. All right. I go to 3 and go right 3 down 2. That's my vertex. All right. Then I have my, in this case, they asked for my focus. My focus was 3, 1. Let me just see if maybe if I make it a little bigger. That's why. Hold on. All right. My focus is 3, 1. So my focus, I'm going to put that in a different color. Let's do purple for the focus. The focus is 3, 1. So I'm going to go over 3, up 1. That's the focus. Remember? So now let's look at our directrix. My directrix is going to be y equals -5. That is a line. Y equals -5 would be a horizontal line. Excellent. Then x equals 3. That's my axis of symmetry. So my axis of symmetry is x equals 3. That would be a vertical line. Then it opens up. So I start at my vertex and it just opens up in both directions. All right. So what I would like you to do, guys, is try number 2 and 3. Okay, so 2, 3, and actually let's do, no, just try it for today. Try number 2 and 3 for today, and then we will continue with this tomorrow. I hope you guys have a great day. If you have any questions, please come to office hours, and I will talk to you tomorrow. So 2 and 3 from this packet is your assignment for tonight. Have a great day.